All right, so this video is a continuation of the last video where I explained the difference between scalars, vectors, and unit vectors. All right, so you may remember this crude sketch of little Timmy riding his bike through two separate displacements. Before we get to finding the magnitude of the resultant here, I should point out my error from last video in that this right here, the second displacement, really should not be x2 because he traveled in the y axis, right, along y. It really should be just y instead of x. And because of that, we don't really need a 1 and a 2, just x and y, right? Two different displacements, one purely in the x direction, the other purely in the y, okay? All right, so our goal is to use these two perpendicular displacements to solve for the magnitude of our vector, which is the resultant of the two. First, let's write out this entire total displacement in vector form, right? So he has basically x vector plus y vector, right? I can write it this way because each term is in vector format. Let's break up each of these terms. So if I were to break up this one here, x vector, all vectors, remember, need a magnitude and a direction. So the magnitude was 10 meters and the direction was I hat, right? Remember, I was for x, j was for y, k was for z, if you ever use that. And then we're adding on to the magnitude of the second displacement times the direction, which was minus j. And so we can write this as, and I'll take out units for brevity. We have 10 I hat minus 5 j hat. Right? That's the entire overall displacement. Notice I'm saying displacement, right? Displacement delta x, that's the vector, and that's not necessarily the same as the distance, which was just x, okay? All right, so both of these are perpendicular. We need to use Pythagorean theorem then to find the magnitude of r. So we have, well, we have our equation, so we need to find the magnitude of every term. How do we do that? Well, for starters, the magnitude of every term can be written like such, right? Now, you might think these are simply absolute value bars, times 2, right? They're not quite the same as an absolute magnitude, right? It's a absolute the magnitude. In terms of vector magnitudes, the double bars on both sides specifically mean, well, the following, right? This can also be, well, it means, let's write it here actually. Oops. It means x squared plus y squared, right? Quite simply. And so what we have, do I want to write it like that? Yeah, might as well. Okay, sorry. Let me go ahead and just write both sides down here. I'll write an entire new expression. The double magnitude bars on both sides can also be written as just the variable, right? So just r, just x, or just y. So if we want to find the magnitude of r, then we have to have the magnitude of x and y and then square root, right? That's a better way to write that. And so what we have is, well, 10 squared plus 5 squared, square root of all that, which is square root of 125, which is about 11.2. Okay, so the magnitude of his resultant displacement, right, is 11.2 meters. And now that right there is just a scalar, right? 11.2 meters is a scalar. To make it a vector, we need direction. So we need to find how far down from positive x, right? And since we know both, say, A and B, right, side lengths, we know the adjacent and we know the opposite to that angle theta. Remembering SOHCAHTOA, that trig function then is tangent, right? Tangent equals, what is it, opposite over adjacent. So solving for theta, we just take the inverse tangent of both sides, and then our opposite from that theta was the magnitude of the y displacement, which was 5, and our adjacent was the magnitude of the x displacement, which was 10, right? Inverse tangent of 0.5. I probably should be able to do that in my head, but I can't. That should be 26.57. Okay, maybe I wouldn't have been able to do that. Yeah. So 26.57 degrees, we can say, what's that? Clockwise from x. Right? Or if you want to say it as really negative 26.7, you can, but I'll say clockwise from x, the x direction. Okay, so that's how you find the magnitude of a vector. You have to have the components be perpendicular, and in this case they are. One component is purely in the x, and the other component is purely in the y direction. Then just use Pythagorean theorem and inverse tangent to get the magnitude and direction of the resultant.